Assalamualaikum warahmatullahi wabarakatuh to our lecturer Sir Muhammad Zulkarnain Hakim bin Abdul Jalal and all of you that watching this video. Today we will present about our group assignment QMT342, which is Fundamental of Operation Research. So we are going to present about optimization of waiting line at Texas Chicken. Before we start, let me introduce our group member. First, that is me, Muhammad Ashraf Fitri bin Muhammad Kamal. Second, we have Muhammad Adam Iman bin Ahmad Junaidi. Third, we have Muhammad Alif Luqman bin Muhammad Sabri. Last but not least, we have Muhammad Anwar bin Muhammad Dali. We all from JCS 1435C. Before we go further, let me present about introduction first. The location of Texas Chicken Segamat is at number 143 and 144 ground floor, Plaza Center Point, Jalan Datuk, Jalan Siah Heyam, 85,000 Segamat, Johor. And the operating time for Texas Chicken Segamat is from 10 AM until 10 PM. The observation time that we chosen is from 8 PM until 9 PM in the range of 1 hour. Next, the number of servers that Texas Chicken Segamat have during the time of our observation is 2 servers. This is the picture during our observation process. Next, my friends Alif will be present about characteristic of queuing system.
Assalamualaikum. My name is Muhammad Alif Luqman bin Muhammad Sabri, and I'll be representing about arrival characteristic. In arrival characteristic, we have size of the population, pattern of arrival at the system, and also behavior of the arrival exist. So for the size of the calling population, it is unlimited. The customer come to the outlet at any time for getting their foods and drinks. And next is for the pattern of arrival at the system. It is a random Poisson distribution, and from our observation, we get 16 customers per hour that also represent as our lambda. And last but not least, behavior of the arrival exists. The customer are patient and will wait in line until they are served, and they are not switching lines.
Assalamualaikum. My name is Muhammad Adam Iman bin Ahmad Junaidi. I will present about waiting line characteristic that our group have surveyed at the Texas Chicken Segamat. First, the length of the line is unlimited, where at this Texas Chicken branch, every customer who queue will be served to order. Second, queue discipline, they are used in first in first out, FIFO, which means the first customer who arrive will be served first. The special facility characteristic at the Texas Chicken Segamat. First, the type of channel are multi-channel system. There have 2 total of counter at the Texas Chicken Segamat. Next, the type of phase is single phase system, which means the customer will be served at one station. And lastly, the type of waiting lines are multiple lines that have 2 lines at the Texas Chicken Segamat. For the pattern of service time, we assume service time follow an exponential distribution with 18 customers each hour, resulting in an average processing time of 3.3 minutes for each customer. The queuing model at the Texas Chicken Segamat are multi-server, multi-line, and single phase. The customer who arrive will queuing at the line to order. After they have made their order and payment, they will wait for their order done. Once their order is ready, they will take it and leave.
So let's move on to the result section. We are getting arrival rate is equal to 16, service rate is equal to 18, and number of our server is equal to 2. So right now we want to find the probability of system is being used. So that is our formula, P equal to lambda over M times mu, where M is equal to 2, lambda is equal to 16, and mu is equal to 18, and we get the result is equal to 0.444. Move on to the second. We want to find the probability that no customer in the system. That is a very crucial part if you want to find the information like average number of customer in system or time spent in system. So that is a formula to find the probability that no customer in the system. To that, you insert the value and we solve it, and we get the result is equal to 0.385. So for the next part, we want to find the average number of customer in the system. So as you can see, in that formula we have the P0, which is the probability of no customer in the system. So after we find the probability of no customer in the system, after that we can use the formula. So we insert all the value into the formula and we solve it, and we get the average number of customer is equal to 1.11, which is equivalent to the one customer. So move on to the next part. We want to find the average number of customer in the queue. Same for the previous part. If we want to find the average number of customer in the queue, we first must to find the average number of customer in the system. So the formula is given, LQ is equal to L minus mu times over lambda. So we insert all the value, 1.11 minus 16 over 18 is equal to 0.22. So right now we want to find the average time customer spend in the system. So the formula is given, W is equal to L over lambda. So we insert all the value, 1.11 over 16, and we get the result is equal to 0.07, which is equivalent to 4.2 minutes. So for the last part, we want to find the average time customer spend in the queue, which is the waiting lines. It's given by the formula WQ equal to LQ over lambda. After that, we insert all the value, 0.22 over 16, and we get the result equal to 0.01, which is equivalent to 49 seconds. So that is our output when using a QM for Windows. So it's same for our previous part, which is average server utilization equal to 0.44, average number in the queue equal to 0.22, average number in system 1.11, average time in the queue 49 seconds, average time in the system, which is 4.2 minutes.
So for the conclusion, give a comment on the number of servers provided and the customer's waiting time. So for the first question, is the number of the servers provided adequate? Yes, it is, because the rate of the customers being served is faster than the arrival rate of the customer. Next, are the customers happy with the waiting time? Yes, the customers are happy because they don't need to wait for a long time to be served. Next, describe what you have learned from doing the project. So our team learned from doing the project is, if average service rate mu is larger than the average arrival rate lambda, it shows that the customer will get served at faster rate when they arrive. Meanwhile, if the average arrival rate lambda is larger than the average service rate mu, the queue will get larger and the waiting time will be longer. Thank you.
That's all from us. Thank you for watching this video. We hope you guys can get benefit from our video and can use it for further study.